Hello. Today we're going to be reviewing graphing rational functions and also how to write a rational function given a graph. So if we're looking at this, how do I find the equation or possible equation? So if you're looking at this, what do you see? What do you notice? So it's really working backwards from what we've done before. So I have a vertical asymptote. So you know that has to do with the denominator. I have a horizontal asymptote at 1, so that has to do with the degree in the front. And the leading coefficients must be the same or equal 1. What else do I know? I have a x-intercept is 1, 0. The y-intercept, I'm not sure. It looks like a net positive a half, but could be slightly more or less, so we'll check that. And then here, don't know if you noticed, that is a whole. That is a whole of 3, 2. So at x equals 3, right, there's a whole. And that also has to do with the domain as well as the denominator. So we're going to start here. Go with my vertical asymptote. So I know it's this, right? It has to be the opposite. And I know because a whole in the denominator, it must be that. But because it's not a vertical asymptote and it's a whole, then that means there's an x minus 3 on top because they're going to simplify out. Now, because of my x-intercept, I know I must have something up here, and so this is going to be the opposite. Okay, so how do I check to see if I'm right? Well, I know that if I write, we've talked about simplifying the equation. So if I simplify and cancel out the x minus 3's, I'm going to get this. So I'm going to test it for a moment and try some things with it. So if I have this, right? If I have 3, should come out to 2. If it's not, then my equation's wrong. So 3 minus 1 is 2. 3 minus 2 is 1. So yes, that does give me a whole there. Also using this, you can check our horizontal asymptote. N and M are both 1. A and B are both 1, so that would make it 1 over 1. If I set the numerator to 0, that would give me this. My x-intercept. If I make the x a 0 for my y-intercept, that would get me a positive half, and that looks like a positive half. So this equation is good. So you can leave it in factored form, or we could multiply it out. And there, I like it. Okay. Next one. All right. So what do we know? So I'm going to say this is x equals negative 3, right? Because it's in between. I'm going to say that's a positive 3. Okay. So y equals negative 4. Now x-intercepts and the y-intercept is that. Okay, so where are we? So I'm going to start with the denominator. X plus 3, x minus 3. Now some of this is a little guess and check, and you just kind of have to work with it and change things up. So I know that this is, if I multiply it out, so because of this, and the y-intercept is negative, not the y-intercept, the horizontal asymptote is negative 4, and they have to have the same degree. I know this has to be an x squared here and a negative 4. Okay. And I'm going to say, so that's here. Now, because of this, we know that the constants at the end, that's what makes the y-intercept. And the y-intercept looks about 1-ish or slightly less. So if you want 1, this is 9. So that would be a negative 9. Okay. And I think that's good. Yep. Okay. So I'm going to say, or 8, -8 maybe, because our graph is not exact, doesn't give us more numbers or points, so it's slightly harder to tell for this one because your scale is going by 2. All right. So we've done this before, but I wanted to review it because several people, I think, might be confused because there was too many things going on, and I just wanted to simplify it. So we're looking for N and M, and this is to find horizontal and oblique asymptotes. It's looking at that degree, the biggest, exponent, largest one in the numerator and denominator, and comparing the two. And then here is A and B. A is the leading coefficient in the numerator, B is the leading coefficient in the denominator. And I wrote different cases here, and so just wanted to go through it quickly to review. All right, so here if you're looking at is there an x, the answer is no. So because there's no x, that means x was 0, which goes to 1. So n is 0. So if you don't see an x, that's 0. And then n is 2. Okay, so clearly n is less than 0. And this would be case 1. Right? Case 1. And therefore, it says horizontal asymptote at y equals 0. All right, so look at n and m for the next one. Can you find them? So this is n and m. So they're both 3. Right? So it's equal. This is case 2. And what does it say? It says, okay, y equals horizontal asymptote. You have to find a and b. Remember, it's the leading coefficient. So this is where you circled the n and m. This is a, and that's b. So it's y equals 6 over 2. Yes, you have to simplify it always. Equals 3. Okay. So this one, we have n is greater than m, plus 1. So here n is 2, and m is, now this is where the confusion, like a couple people were like, this is 0. No, because you can see the x, remember? If I just have a plain x, I know there is an invisible 1 in front, and there is a power of 1 on top, right? So it's x to the first power. So that is actually 1. So n is greater than m by 1. They're consecutive, and then this is case 3. Now I'm not going to do the oblique asymptote right now. It's long division. Just note that that is long division. I'm just reviewing this. Really, it's about understanding this. Okay. There you are. So this one, what is n? 3, and m is 4. So n is greater than m by 3, right? So that's definitely 2 or more. So that tells you there's no horizontal asymptote and no oblique asymptote. And that's it. All right, I just wanted to review graphing rational functions. So take a moment and pause, try to do it on your own. I'm actually going to go pretty quickly through this and not show as many steps as normal. Okay. So I am going to factor first because you have to see if there's a hole or not. And the factoring will help us find points later on and really all the different pieces, right? Domain, vertical asymptotes. X can't be 2, and x can't be -1. So the x-intercept, you said so it's similar to the vertical asymptotes in the domain where you set the denominator not equal to 0. For the x-intercepts, you set the numerator to 0. So it's going to be the opposite of here. So it's going to be 4, 0, and 1. The y-intercept, remember, you're substituting all of these for 0. The x is for 0. So that's going to leave you 4 over negative 2. So my point is 0, negative 2. There's no hole. Okay, please note that. To see that this is both ones, but one's negative, one's positive. So there's nothing to simplify out. So that's none. So I'm going to go back to here about n and m. Okay, how much is n? 2. M is also 2. So this is case 3. Oops. I said too many things. Sorry, case 2. Oh, I had it right. So it's case 2. So that is A and B, which is horizontal asymptote. A and B is 1. A over B is 1 over 1. That's 1. Okay. And go graph. Don't forget your scale. Vertical asymptotes at 2, negative 1. Horizontal at 1. X-intercepts 4, 2, 3, 4, and 1. Okay. Y-intercept is negative 2. That's down here. Okay. So you can see it's divided into 3 pieces. Because this is up and down, and it doesn't look like it's going to loop back like a parabola. It looks like it's going to be like that, which is a cubic. So it looks like a cubic in the center. All right, I'm going to need another point here in this region, bottom right. And so I'm going to take 3 right there. Okay. So f of 3, put it into my factored form. So it's going to be negative 1, that's 2. It's going to be 1, and that's, is that right? Oh, 4. Okay, so that's negative half. So that gets me here. Okay, that's good. So that's me like this. So on the left side, I'm going to pick negative 2. It's negative 6, negative 3, negative 4, and negative 1. So that's 18 over negative, positive 4. 18 over 4, that's a 4 and a half. So 1, 2, 3, 4. All right, so that was at negative 2. So I think I'm going to pick another one out more. Let's see, I'll go with negative 4. So it should be closer to that horizontal asymptote, negative 8, negative 5, negative 6, negative 3. Okay, so that's 40 over 18. 18 times 2 is 36, so it's 2 and something. So that is 1, 2. Okay. So it looks like it's going this way and going down. Lovely. All right, one more. Okay, try this one. Pause it and then unpause when you're done. 2. Oh, look at that. Okay, immediately I know that's a hole. Okay, but I'm going to do the domain first before I try to simplify it out. Okay, so the whole, right? Vertical asymptote, so the whole is here at x equals 2. X equals 2. So I have to find that point. So my new equation I'm going to use is 1 over x plus 2. Okay. So my vertical asymptote is x equals negative 2. Okay. So you set the numerator to equal 0. You set for the x-intercept, you set the numerator to 0. Now, is that true? No. So this is, what do we say that is? So there's none. There's no x-intercept. Y-intercept, you set the x is 0. So it's going to give you a half. So my n is 0 because there's no x in the top. M is 1. So that is case 1. So this is a horizontal asymptote of y equals 0. Okay, so then I have to find where that hole is at that point. So g of 2 is 1 over 2 plus 2 is a fourth. So my hole is at 2 and a fourth. Okay. And horizontal asymptote, vertical asymptote. Horizontal at 0. No x-intercept, that would make sense because my horizontal asymptote is at y equals 0. And then I have 2, 1, 2, and a fourth. So just above. Okay. And then this is a half. Okay, this is a whole. So I should make it a whole. Okay, I'm going to put in negative 1 because it should be up here somewhere. Let's see. F is negative 1. Oh, G. And I'm putting in capital G. So it's 1 over 1. Right, so that's easy. Negative 1 is 1. So it's going like that. Hole, jump. Okay, you don't want to fall into the hole. All right, so that's a 2. So I'm going to pick negative 3. So it's 1 over negative 1. So that's negative 3 is here. Okay, and then I'm going to pick something, let's say 3. I'm going to move it over, but negative 3 or 4. How about negative 5? Negative 5. So it's 1 over negative 5 plus 2 is negative 3. So that's now a third. All right. And there you are. Hopefully that one wasn't so bad. Just getting used to holes. All right. So remember all the different pieces. Take really good notes on how to find each thing in your own words and your own writing. Sentences will help. Right? Thanks for watching. Bye.